Good morning. Good morning. And welcome to this live coding session with Snowfrog Dev. So what are we working on today? That is the question, isn't it? I was getting tired of working on you know, puzzles and exercises and stuff. So I figured I would do um, something that's potentially quite a bit more boring, but interesting maybe, and practical. So working on a lot of those puzzles and exercises, you need to make use of a lot of data structures, different data structures, stacks, queues, graphs, multi-dimensional arrays, etc., etc., etc. And I always find myself pretty much, rolling out an implementation of these by hand from scratch every time. Um, I've looked at, so I'm doing this in TypeScript and JavaScript, right? That's what I work in most of the time. And just give me a sec here. Okay. And I was looking online the other day on NPM and GitHub trying to find um, a library that would provide this for me. And I found this. There we go. Okay. Found this one here, TypeScript Collections. And clearly just a port of the C# collections library. Uh, just looking at the the signatures and the method names and stuff like that, it looks to me like it's um, was heavily inspired by C#, which is fine. Um, it's a starting point. The thing is, when I'm looking at the implement, oh, look, and this guy's got linked lists, dictionary, multi-dictionary, linked dictionary, binary search tree, stack, queue, set, bag, binary heap, priority queue. So that's pretty good. And it's all typed and stuff. I didn't do a deep dive into the code, but uh, there's one thing that kind of threw me off and made me decide not to just use this guy's collection library and instead maybe roll my own. Um, let's see. Let's take. Did he make? No, he didn't. Okay. All right. Let's take a stack. All right. There we go. So this is and the code. He did a really good job, I find, of documenting everything, the public API of his library, um, which makes it easier to figure out what's going on and how he implemented all of that. But all right, so you've got your stack class here. Um, yeah, okay. You've got your stack class and all its method, pushing, adding, popping. Wait, add. Pushes an item onto the top of it is the same as push. They're just aliases, I guess. Interesting. Okay, and peak. So, things you'd be expecting. Oh, you even implemented a for each. That's cool. Um, but, but, look at where he stores the elements in a linked list. All right. Now I could go look at how he implements the linked list just for kicks. Yeah, so he's using just a straight vanilla, linked list node object with a pointer. Oh, it's not even a doubly linked list. Doubly first node, last node. I guess it depends how we implement it. But anyways, my beef with this is that looking at, let's look at the set. Okay, he's using a dictionary to hold the values. That's cool. And in the dictionary, he's using just a plain object. So I don't know when this was written originally, at least 3 years ago, right? But in terms of performance, I'm pretty sure this is not very good. Like using a linked list for a stack in JavaScript is. I'm going to do some performance testing just for just to make sure I'm not talking out of my. But the array, the built-in array object in JavaScript is super optimized by the JavaScript engines, and I'm pretty sure, and I'm gonna back this up by some tests, but I am pretty sure just from what I'm reading and some tests that I've done in the past, and so that, for instance, the V8 engine, which is behind Node and Chrome, so pretty much the most widely used JavaScript engine, optimizes the array so that how in JavaScript dynamic the array is a dynamic array, so it's not, and there's pointers involved and stuff like that in the most basic implementation of the array in the JavaScript engine, especially if you have arrays that aren't typed, or should I say that don't contain the same type. So in JavaScript you can have your first element have a string and the next one a number and the next one an object. So if you do that, then yeah, performance is gonna. But if you don't, if you're smart and you just do, okay, this array is only numbers, then the engine will optimize the crap out of it, and it'll be very performant. I mean, relatively, and even for operations where you think they'd normally be O of n, like shift and unshift, like adding and removing an item from the front of the array. Even that they optimize into O of 1, like constant time, I think. Now, anyways, for a few years they have been optimizing it that way. So really, when you're doing a collections library in JavaScript, your first, your go-to base structure should be the array, because it's optimized and usually it'll be the fastest option. And this guy pretty much went ahead with making a linked list the base of his other data structures, or some kind of dictionary which is built on just a basic object, and there too probably a map would have been better, though I'm not quite sure. I could do some tests on that. But anyways, all of that to say that that's why I'd rather try and replicate this. This guy's he did a pretty good job though of like making a clean library though, so kudos for that. And I can probably take example from that. I don't know if I'm going to be doing all of these, the same data structures that he did, some of them, and I will too get inspired by the C# collections library. But not only that, I think I'll look at Java too and some other things to decide which, just for starters, which data structure I want to implement and how I'm going to implement it, how I'm going to name the methods and what they're going to do exactly. So I'm keeping that for reference on the side here. Oh, not there, sorry. Let's use this thing here, okay. Now I'm going to show you a collections JavaScript, probably the most popular collections library for JavaScript. So the other guy was built in TypeScript, but I think it was compiled to, well, of course it was compiled to JavaScript. So it could be used in JavaScript and TypeScript, and that's what I'm shooting for too. This one here, I think, is pretty much only for vanilla JavaScript. And I like he's got a lot of interesting data structures that he implemented. And I think that guy was a little bit more concerned with performance. So I might look at some of his implementations. Let's see, what was I looking at? So this guy doesn't have just a queue. Does he have? See, that's the thing. So this guy doesn't have a queue. He only has. He's got a bunch of other interesting ones though. The thing I don't understand is like, why does he have these are okay. He probably just augments this by, oh yeah, okay. He probably adds to the built-in array some, yeah, poke. Now, I don't want to do that. I don't want to like monkey patch the built-ins. That's something that's just a choice. It's not necessarily bad, although it can be, because it could screw with some other libraries you're using. So I'm not going to do that. But see, this guy doesn't have a queue, and there's probably, oh, okay, he's got a deq, a deq, double-ended queue. Okay, and I think you can just use that as a normal queue. And let's see. So the other guy implemented the queue with a linked list. How does he implement it? He's got a lot more. So he's got a really wide API. I probably want to make a leaner API. But, you know, that's not wrong. Let's see if we look at the GitHub, the source code for, oh no, that's the TypeScript collection one. All right. How does he implement is a deq, double-ended queue. Where is it? Where is it? Where is it? There it is. Now let's hope it's not written in, you know, 2009 type JavaScript with like immediately invoked functions all over the place. And okay, no, it looks like you can probably make heads and tails of tails of this. Petka Antonov is the library author. deq specifically uses a fill count. Cool. Incrementally maintains length. Modulus avoided by using only powers of 2 for the capacity. Okay, so that's an interesting restriction. So, but that's essentially a if it's a double-ended queue, is that like a circular? Anyways, I'm not going to dive too deep into this right now. What is he using in terms of where does he store the items? That's what I'm interested in. Oh, interesting. Okay. I think I understand in it. So he's basically rolling his own index system. Length, front, and capacity. Okay, so from what I understand, just quickly, capacity is a number that is, how does that differ from length? Okay, length is probably the number of items that are in the queue. Capacity is probably the maximum space. So it's capped, unless it's dynamic and it can change. But we're looking at the constructor here, and it looks like it's being set in the constructor. It doesn't mean that it won't change, though. Max capacity. Okay, so he's got some sort of bitwise operation here to determine the capacity. Okay, so this is more advanced than I have, you know, looked at for this so far, but obviously if the guy's doing it this way, it's because he thought about performance and he figured that this was the best performance. But here's the thing. As I have just said, for a few years now, but not that long, the V8 engine and probably the other ones um, is really, really optimizing the array, including shifting and unshifting, because that's been traditionally the slowest part of the operations on a JavaScript array is taking from the front or adding to the front of the array. And apparently, from what I'm reading, they managed to optimize that for constant time. So you have to wonder what's the benefit of trying to roll out your own fancy implementation of these data structures. Now, the primary reason why I'm doing it is that I don't like the API, right? The JavaScript array is a super versatile data structure, and it's it should really be your go-to for everyday stuff. But when you end up working in something that you really need to use your data structures a lot in different ways, and an algorithm is really based around how a certain data structure works. For instance, if you use a stack, that's a perfect example actually. So if you use it here, let me just I'm not gonna do this in here. Let's go, there we go. So if you use a stack, like normally, in a lot of languages or other libraries, you do, all right, here's my stack, creating a stack. So new stack, and you might be able to pass in some stuff right in there, or you end up adding after that. And depending on the library, you do stack dot add might be what it's called, and then you put your value in here, and then it could be stack. Well, normally I think for stacks they would use pop and push. So you're pushing onto the stack number 12, and then you're popping, number 11. Cool, good stuff. So obviously the array has the same thing, right? Array in JavaScript has, oops. Yes, auto import sometimes is, let's just do that. Okay, create our array, then go, and we have pop, right? So cool. And it does what you think it would do, and you have push as well. So that's great, right? So the array pretty much already has your stack API, except that most stack implementations also have something very useful called peek or top, depending on the library, which gives you access to the last element of the data structure, that the top, basically, what's on top of it, right? Because a stack is like you add from the top, things add up, then you remove from the top. So, but pop actually removes it. It returns the item, but it removes it from the stack. Sometimes you just want to have access. Oftentimes you just want to have access to whatever's on top and not actually remove it. Now, if you want to do that with an array, it's not that big of a deal. But if you have a lot of code that needs that, it gets annoying. So you need to do array, then access the last element of the array. That's what we're doing, right? So how do you do that? Well, you do r.length. Oh, but r.length is not the index, it's the number of items in the array. So that would, so you need to one more. So you remove one. So that's the equivalent of peek, right? So now that's not too bad, but let's say you're naming your things properly and your array is called, I don't know, vehicles or something even more, like display colors or whatever. So you end up having to be, okay, I want to peek on the last one, so display colors. Um, display colors. Uh, colors dot length -1, right? Okay, so what do you prefer? Colors, display colors dot peek, or this? And this, you know what you're doing. All right, I'm peeking, or if it's called top, you know what you're doing. Here, you're like, well, okay, I'm getting the index. That's blah, blah, blah. So, in terms of API, so this is cool. We've got this on the array, but we don't have that, and it's a useful one. And there's other ones too that you might want to add to a stack, and that's just one example. Um, And the array also have shift and unshift, but for a queue. But like I said, in terms of API, it's missing some things. Some of the naming is not really that great. So it can be a useful thing to have your own collection, to add some more custom kind of methods, and also restrict, right? Because let's say I want to use a stack as a data structure. Because that's the only way I want to use this data structure. I want it to be impossible for this data, for me or anyone else using my code to grab items from the front of my data structure. Well, technically, an array can be used as a stack, but if I use an array and then I pass it to a client, or which I shouldn't be doing, or whatever, but it just makes it a lot more easy, makes it easier to do things you're not supposed to do with that collection. If it really was intended to be used only as a stack, which often it is, right? Or as a queue or whatever. So having your own more restrictive kind of data structures and collections and stuff like that is a good thing for that too. So there's many reasons why you would want to have a custom implementation of some data structures in JavaScript, even though the array is pretty good and is versatile and you can do a lot of stuff with it. Those could be some of the reasons. So this is interesting. This guy seemed to have optimized some stuff. I am curious to see if let's say a stack or especially a queue, because oh, that's interesting. Does he even implement the stack? Probably not, right? He probably goes like, we'll just use an array, right? Yeah, yeah. So, this guy at least recognizes that the fastest data structure in JavaScript library is, it's the array. You can't go faster than that. So what I'm going to do, enough talking. What I'm going to do is actually implement a bunch of different data structures, and I'm going to use the array as a base. I'm going to implement them, and then I'm going to test them for performance against some of these other known libraries that I've just shown you. And then maybe optimize, we'll see. But I'm primarily interested in having a nice API and decent performance. So if I have to do a trade-off for some edge cases in terms of performance, I don't mind if it means keeping a practical API. But we'll see. All right. So I will, to do this, and I kind of started a little bit in my other project in Code and Game here where I am, right? I kind of started the other day by building just an interface and an abstract class. But I think I'm pretty serious about doing this, so I'm gonna actually just start a project just for that. Let me use my little tool here. We're going to call this Collections TS. For now, anyways. We'll have to think of a good name when time comes to push this to NPM, right? Because I'm going to make it a public package eventually, I'm guessing. Yep, I want this to be more of a library. Do you want to initialize a Git repo? Yes, please. Good. Let's get in there. Actually, let's just use a new window. Folder. Collections TS. There we go. And I don't know why if anyone knows why my terminal does that, but in VS Code, when I open the built-in terminal, the command prompt is like up here. It's really kind of weird. See how I'm scrolling here? So this is what I'm being shown at the beginning, but the command prompt is right up here, but I actually type here, I don't know, so I just go CLS and it's kind of weird. Okay, what do we have here? Okay, it's giving us roll up, so that's cool. It'll allow us to make bundles. It'll make a UMD bundle, it'll make a CJS, and an ES bundle. Cool. TS config, let's target ES6. Common JS modules. Library, we're going to need ES6. I want to use those features. Right. What? That's a valid flag. It's right there. What does it say? Argument for lib options must be. Well, it is. That's kind of weird. Sometimes, huh. Okay, if I do, maybe if I do it that way, it'll, now what? Requires a value of type string. There's something in the file that is throwing off the kind of linting. Okay, now it's shifted to this. Specify library file to be introduced. Requires TypeScript. Okay, expected. Well, it's here. Dude, well, what more do you want from me? Stop it. Okay, there you go. So that's good for now. Now, the rollup config I think is pretty good. It'll, what's it doing? Name collection TS. And let's look at our ignore package.json. We have, okay, our dist folder, main module browser, cool. Probably should npm update. Can I do that? Don't know that it changed anything. Okay. Dev collections TS. What else do I need in here? I don't. Let's get the node typings in here. So it's npm I types node. Okay. Good. Oh, this should actually be a dev dependency. Don't need this after all. Okay. So I think we're set up for start. Now I'm going to be testing this thing eventually. I wanna prototype this a little bit first before I go into testing. So I'm not going to be doing this TDD style. At least not right now. So let's call this add node typings. Okay. Interesting. It looks like my chat thing's not working properly. Let's give this a try. This is a test. Welcome to the chat room. Okay. And here's another. Okay. So this one showed up. And here's another. Cool. All right. So let's just copy over what I'd started doing from here. I'm going to need, did I just do this one? I think I just did this one. Copy this to here. I'm not going to use a main. Well, oh, how should I do this? Yeah, I'm going to need to have like some sort of index at some point. But okay, for now, let's just paste that. Oh, doesn't work, eh? Doesn't work from one window to another. Can I drag it? Let's try that. Drag it in here. Okay, that works. And I made a copy, it didn't move it. Good. So I can just shut down the other window. There we go. Okay. What did I do here? So I made an interface collection. I'm doing this with generics, by the way. It extends iterable. Iterable is a built-in, well, it's not a built-in interface. It's a it's a built-in TypeScript interface to represent a JavaScript concept. And implementing this forces you to implement the symbol iterator, which is what the for loop in for of loop, no, the for of loop in JavaScript, sorry, uses. So we want to be compatible with that. Now there's a few things we might want to think about. Do we want, so what do I have here? I have a size. I have, so a size property that'll return, well, it won't return as a property, it just holds. It holds a number, which is the number of elements in the collection. I have an add, which is, it adds items to the, or elements to the collection. Clear removes everything. Has determines whether the collection includes something. Remove removes the first occurrence of a specific element from the collection. Cool. So that's what I got. Add, remove, has, clear. That's my base interface. Now I went ahead, that's right, and I built an abstract collection class because I know that for most of the collections I'll be implementing, I'm gonna lean on the JavaScript array. So I just went ahead and implemented that. Although I am, protected, so that means subclasses will, or concrete classes will have access to it. The size, I made a getter for that. Right, so basically you're accessing it as a property in your code, but it's actually a getter and it gets the element's length. Yeah, that's sensible. And so that's a concrete implementation. Returns an iterator over the elements contained in this collection. So there's my iterator. I made it an abstract, so that means that concrete classes will need to implement this. That's interesting. Should I just go ahead and maybe just do a concrete implementation of that in the abstract class? Well, if I do that, there's no longer any abstract. It's my only abstract. So if I do that, it's, well, would they be like if for most of these I use the array as the base collection? Would there be an implementation where you would have an iterator that doesn't basically do the same thing as the array iterator? Because I could save myself some work if I just, well, if I don't make it an abstract, I can still override it, right? In a subclass if I wanted to. So why not go ahead? If I think that for most of these I am going to be using the array's own iterator, why don't I just go ahead and implement that right in here? So if I do this dot elements, which is my array, let's see, values returns an iterable of values in the array. Right, that's pretty much what we want. So why don't we do that? There we go. It works. It works. Okay, what else do I have? I have the add, I have the clear, I have the has, I have the remove. Cool. Cool, cool, cool. So those are pretty much your basic things that you want to have in every single collection, no matter what kind of collection you're implementing. So I think that's a pretty good base. I mean, we might revisit this base class, abstract class. Well, now it's really just a base class, right? I don't have any abstract do I? I don't. I don't have any abstract. Even this is not abstract anymore. I guess I had it abstract at some point. So it's more of a base class, and actually we could just use it as is, right? But we don't really want to, because I could have made this like a base collection instead of abstract collection. But I might change my mind and make some of these abstract again. So let's leave it like that, and we'll see as we go. Now, the question is, what is the first collection that I should be implementing? I have been reading lately this book called what's it called? It's a pretty old book. It's at least 20 years old. It's about game. I think it's data structures for game programming or something like that. The examples are in C++, I think. But they're easy enough to follow, even though I don't know how to really code in C++. But I think these are like pointers and stuff, but whatever. And he gets us started with an array and then linked lists. Now I'm debating whether or not to even implement the linked list. I don't honestly. Actually, that's a good thing to think about for starters. And here's the thing. Let's think about this. If we just look at data structures, time complexity. Because each data structure is supposed to have its strength and its weaknesses in terms of performance. Okay, this could be interesting. Let's go look at that. Or this one here. Oh, I think I've been to this one before. Oh, it doesn't exist anymore. All right, so just quick recap. You don't want to be here, you want to be there as much as possible. Those are algorithms. Just show us the data structures, please. What? That's all you got for us? Just, okay. So let's forget about that. That's for Java. Oh, in JS. Oh, that's where I was. Okay. There's another big old cheat sheet. Ah, that's nice. Okay. Data structures, comparisons. So, array, and that's a real array. So technically not exactly like the JavaScript array, but still. In a sorted array, okay, there we go, linked list. So, or doubly linked list. For sure, I wouldn't implement just a singly linked list. I can't see an advantage to that. Oh, wait, actually he's showing. Well, that's interesting. Insert, okay, but that's like at the end. Average case, worst case. I'm not sure this is accurate. I'm not sure I agree with this. Doubly linked list, search O of n. That's not. Oh yeah, worst case. Delete. No, that's not specific enough. I want something else. Okay. Nope. Algorithms, data structures. Yes, this could be interesting. No. I want to see, yeah, I need something that shows the time complexity of adding and removing from the top and from the bottom, or from the start and from the end. That's what really shows us the differences. maybe in the book itself. I think he introduces the concept. At the very beginning, maybe. Basic algorithm analysis, probably in there. Concepts. Okay, there we go. Big O notation. There we go. Nope, that's not it. Oh, come on. Maybe at the end and some sort of introduction to the standard template library. Nope, 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 nope. Okay, forget this. Anyways, the thing is, I don't think there is an advantage to using a doubly linked list in JavaScript in any situation. Everything I've been reading and some of the tests I've been doing never show a performance advantage of doing that. And because really the only thing from memory, because I can't find what I was looking for, but from memory, the only advantage of using a doubly linked list in terms of performance is versus a JavaScript array would have been possibly would have been adding and removing from the start of the list, right? The famous shift and unshift in JavaScript. But again, this has been highly optimized now in the latest JavaScript engines, and I doubt that there is a performance gain to be had. And that's really the only thing that would be an advantage in linked lists. And linked lists and also take up a lot more memory. There's a lot more overhead. So for sure, in smaller linked lists versus array, for sure the array's faster. I'm like 100% sure it's the case. Maybe in like huge lists, it might make a difference if you shift or unshift. But there too, I'm pretty sure they've optimized for this if you're using the same data type throughout your array. So I'm not going to bother. There you go. That's been decided. I don't think I'm going to bother with using a linked list in my collection. You see a bunch of articles on them because they're kind of the basis for some other data structures, especially when computers were really, short on memory and CPU and whatever, and apparently it made sense to use that. But I think in higher level languages, especially JavaScript, don't really see a use case for it. Might change my mind later, but for now, let's just skip the linked list and go straight to, let's see, in the book, and I think they're doing these kind of in order of, I don't know, difficulty maybe, or so skipping the doubly linked lists for now. Stacks and queues, yeah. All right, let's start with the stack. That's going to be an easy one. And what are they saying? Okay, we know what a stack is. I want to link. Okay, so they have a linked list implementation. of the stack, and they have an array implementation. Top, if you, constructor. So they have a push, they have a pop, they have a top function, they have a count. That would be our size. Why use an array? Simple as that, right? The API is very simple for what they suggest. Now that's implemented in C++, so we're going to skip that. I was just curious about what API they used. And then it goes on to queues. Okay, and let's get some inspiration too from, let's say, well, let's look at our friend that did our TypeScript implementation, but using linked list. He's got push, add, pop, peak size, clear for each. So we probably want to implement a push. Although we have an add right now, we probably want to implement a push, which will be the same thing, and a pop, and a, okay, so he's got a peak. In the book they call it top. Here it's peak. Size, we also have a, that contains, I think, my API, my base or interface. I'm calling it has, and I'm doing that because that's what other JavaScript built-in collections have, like the set and the map. Both use has instead of contains. So since we're doing this in JavaScript, I'm going to stick with that. Is empty. Okay. I wasn't planning on implementing that, but that might be interesting. But really, okay, let's think about this. What way would I have to know if it's empty or not? I could simply check, right? Check for size, if size 0. Yeah, that might be quite handy actually. So that means that instead of having to do, const, let's say stack equals new stack. Okay, and then I would do stack dot size would get me the size. So if I wanted to know if it was empty, I'd have to do if stack dot size equals 0. So that's what I would do. And now if I implement that method, all I have to do is if stack dot is empty, right? I like it. I like it. It's you don't save yourself a lot of typing, but it's no, I like it, so I might do that. Should I make this into the base class? Would there be a case where it doesn't make sense to have that kind of is empty function? When would I have a collection or data structure where I would never ever want to check if it was empty? I think it would be a useful thing to have. I think it would be a useful thing to have for all collections. So let's throw it in there. And I'm kind of surprised. Let's see. Does JavaScript have that? Yeah, it does. What about C#? Does it have it as a... What am I looking at? That's probably the interface, because I don't think C# has a base collection class. It just has an interface, and then that's it. It implements it from there. Okay. So, yeah, I still like it. I don't want this thing to get bloated, but I think it's pretty useful to have this is empty, and I think it's gonna get used a lot. So let's do it. Am I doing this alphabetically? I think I am. A, C, H, R, except for this because it's property. That too. I'm making it protected so that I can access it from subclasses. That's cool. My iterator, it's a symbol, so I've got it. Okay, all right. So is empty would be here. Is empty. I don't need to pass in any parameters. It returns a boolean. A boolean, not a boolean. A boolean. Okay, and basically all I need to do is return this dot elements. Oh, my mouse is dying. Just gotta plug it in. Go. Okay. Return this dot elements dot length equals 0. Right? And let's document it. Should I make it part of the interface? Actually, now that I'm thinking about it, why do I even need the interface? I could use the abstract. Well, it's nice to have the interface, so let's add it to the interface as well. If we intend for all of our collections to have this is empty, document this, just give it a space. Okay. And what kind of description are we gonna, let's see if we can get some inspiration from Java. Returns true if the collection contains no elements. Cool. Cool. I'm in the abstract class here. If I look at the interface, returns true if collection does no elements. Let's go with that. I like it. Simple as that. Returns true if this collection contains no elements. Maybe just, well, false otherwise. That's pretty obvious, but there. I guess just copy that in the actual returns. True if this collection contains no elements, false otherwise. What would that look like? Good. I can pretty much just copy that. Well, let's just copy that, let's say. Get in here. Is empty. Document this. Thank you. This if abstract collection. Just curious if they describe it differently in the abstract collection. Nope, same thing. Cool. And I could just do this. This should probably be false. Like what? What? Okay. Like that. Turns a boolean. I don't think I had done that in here. I did. Okay, cool. False otherwise. All right, that's taken care of. Let's, for quick tests here, make sure I implemented this properly. So if I do const, we'll call it call is equal to a new, oh, I gotta make it a subclass. Okay, so class, call. Oh, let's pretend we're making a stack, because that's what we're gonna be doing in a second. Which extends our abstract collection. Okay, oh yeah, they're all generics. That's probably what it's complaining about. Okay, so that's what we're going to be doing in a second. And then, cool, I don't need to implement anything. It's saying you've got what you need already been built in. So if I was to do it, I would just go const stack equals new stack, like that. Then I do stack dot add, and I add 1. Yay! And then, 2 and 3 and 4. And if I wanted to check the size, I'd go stock.size. Let's do this. Okay, 4, good. And now if I wanted to do stack dot is empty, I would get false. That's right. It is not empty. But if I did that, stack dot clear. Oh, okay. True. Good. So this works. This all works. Stop quokka. Delete this. Delete that. Okay. Make a new file. We're going to call this stack.ts. Cool. Now I was looking at this guy's implementation. Oh, that's interesting. A for each. Do I want to implement a for each? At this point, I don't care to. It might be a nice to have kind of thing. But, let me think about this. No, I'm thinking about this. You know how I had made the iterator an abstract? No, it was an abstract, and I just made it concrete because I was kind of wondering if we were ever going to iterate through our collections in a different way than just, start to end like in the array. And you might want to do that, like in a stack. You might want to iterate last in, first out. I don't know what the standard here is. Okay, so we'll wait and we'll see. So let's start with this. So export class stack. It's generic and it extends abstract collection like that. Cool. Now let's look at this dude here. Let's keep all of this in the same browser. Got all my collection stuff spread out all over the place. That here, and this dude too. There we go. Bring that up on screen here. So abstract collect, actually, that's interesting. Let's look at what Java does. Java actually makes abstract list, abstract queue, abstract set. Huh. We won't go into concurrency. Although that might be cool. Yeah, I don't know about the use case though in JavaScript. Well, on the back end, maybe. Not a priority. So what are these? If I'm looking at, let's say, abstract queue. This class provides skeletal implementations of some queue operations. The implementation in this class are appropriate when the base implementation does not allow null elements. Methods add, remove, and element are based on offer, poll, and peak, respectively, but throw exceptions instead of indicating failure via false. I don't think we need to do this. I think we can skip these abstractions, in my opinion. I don't think... Oh, I just thought of something. You know how I was going to skip the linked list and all, but if we are intending to use graphs and trees, can we reuse the... Nah. We'll just make a node class when we get there. Okay. So here are a bunch of collections in the C# standard library. System.collections.generic. There's a bunch of those that I think don't really make sense to implement in JavaScript. We have map, we have set, we have the array, which kind of does a lot of these things. But the stack one I like because, as I said, primarily because of peak and the fact that you're restricting and you're being explicit about the way the collection is supposed to be used. You're preventing getting stuff from the front of the array. So defines methods. Following example implements the iCollection interface to create a collection of custom box objects. What the heck is that? What is a box object? I don't even know. Named box collection. Cool, cool. That must be a C# thing, which I don't know about, and there are no links. Okay. Each box has a height, length, and width properties. Oh, that's just for the example. Okay, they're just building a... Okay. That's like a custom... Wait. Oh, I'm in the collection interface. I want to get in the stack. There we go. Following code example demonstrates several methods of the stack generic. Okay, so they're calling it peak 2. So far I've seen peak twice, top once. There's a toArray method. Did I implement that? I don't think or is it even as a... Oh, I think I kind of opted against it because what I'm doing, yeah, uh, I'm making sure that we get an iterator, right? And as long as something is iterable, if you want it to become an array in JavaScript, it's super easy using the spread operator. So, right, because now you can just do, so if I would to implement something, it would be something, okay, so let's pretend we have our stack here, object, and we want it to become an array. So I could implement a toArray function. All right, cool. And then, we'd end up with an array. So I could do like const r equals stack.toArray. All right, good stuff. But actually, in JavaScript, anything that implements the iterable interface, you can just do I was using it as an object. There we go. Simple as that. And it's pretty well known now. It's getting even, most developers know about it. It's super easy to use. It's actually shorter than doing this. Now, the only thing that this has is that it's very explicit. You know what's going on. You're taking your stack, you're converting it to an array. This is, you need to know about the language a bit more. But honestly, I want to keep my API kind of lean. So I think I'm making the decision right here and there that I'm not going to implement the toArray. Might change my mind later. Who knows? Okay. So, no toArray. We're not doing that. Remark, stack is implemented as an array. Yes, that's what I'm doing too. Stacks and queues are useful when you need temporary storage for information. That is when you might want to discard an element after retrieving its value. Used in a stack if you need to access. Concurrent stack, I'm not going to go there. Preserve variable states during calls, blah, blah, blah. Push, pop, peek. Right, that's really, it'll be interesting to look, let's think about the constructor. Yeah, let's do that first. What did our friend do here in terms of constructor? Nothing. So, okay, so he went with the, when you create a stack, it's empty approach. Cool. All right. What about this guy here? Oh, he doesn't even implement the stack. He's basically saying just use the array. Cool. And what if we look at, what's this here? Okay, that's the same thing. So let's take a look at Java collection subinterfaces, non-implementing classes. Just want the stack, dude. Stack. There we go. Stack implements serializable, clonable, iterable, collection, list, random access. So we're just sticking to these two here. I don't think I want to, well, clonable, that's interesting. It's an interesting concept. Let's take a look at this quickly. A class implements a clonable interface to indicate to the object.clone method that it is legal for that method to make a field-for-field copy of instances of that class. Invoking object's clone method on an instance that does not implement the clonable interface results in the exception clone not supported. By convention, classes that implement this interface should override object.clone. Now we don't really have an object.clone in JavaScript. We have let's see, object clone JavaScript. Just 6, why not? We've got assign. Yeah, that's what I was thinking about. Is there something else? A deep clone in JavaScript. Yeah, because if you use assign, that's just a shallow clone, isn't it? You're just getting the first level. Warning for deep clone. For deep cloning, we need to use other alternatives because object.assign copies property values. If the source value is a reference to an object, it only copies that reference value. Yeah. Which, you know, you might want to have. Interesting. Do I want to get in the business of copying, cloning? I mean, how often have I had to do this? Not very often. No, I'm not going to build that in. Whoever needs to do that kind of stuff can just implement its own stuff. So nope. That's a nope. That's a no for clonable. All right. What do we have on here? It inherits from vector. What? Wait. It does. Abstract list. Vector inherits from abstract list. And then stack inherits from vector. What the heck is... Isn't vector like... But vector is not even a collection. How does that make any sense? If it's one of the vector class implements a growable array of objects like an... Oh, okay, it's not what I was thinking about. Like an array, it contains components that can be accessed using an integer. Okay, so it's basically an array. Okay, all right, cool. So that makes sense. That makes sense to me. A lot of abstractions in Java compared to C#. Look at how many layers we have here. Inherits from object, and abstract collection, and abstract list, and vector, then stack. Stack inherits from nothing. It just implements collection. Or does it? Hold on. Inherits. Yeah, from object, yeah, of course. Very interesting. I like this better. Simpler. At the same time, and also for methods, right? Okay, let's start by implementing the methods that they both have in common. Oh yeah, I was saying let's do the constructor first. So constructor, what are our options here in C#? Initializes a new instance of stack class that is empty as the default initial capacity. Now we don't have to worry about capacity because we're using a JavaScript array underneath. And for now, we said we wouldn't mess with that for performance sake, so we're just not going to worry about capacity. initializes a new instance of the stack class that contains elements copied from from the specified collection and has sufficient capacity to accommodate the number of blah blah blah. Okay, so basically you pass in a I enumerable, which is the equivalent kind of an iterable in JavaScript. That's a good idea. We probably want to do that too. And initializes a new instance of stack class that is empty and has a specified initial capacity. So we're not going to implement that. So this empty and this makes sense. Let's look at what Java does. Constructors. Java looks like they just have an empty. You can just construct an empty stack. I like the idea of being able to pass in an iterator, an iterable. So I think I'm gonna go the C# route on this one. So let's start by constructor. And let's see, what's the signature on there? Probably. They call it, if I go look at they call it collection. They call it collection. That might not be the best way to describe this, because we'll be able to take in more than just objects from the collection, from my collection libraries, but actually also maps, JavaScript built-in maps, JavaScript built-in sets, arrays, anything that implements the iterable protocol. Show. Let's look at what JavaScript calls it. For instance, an array of, no, not array of, array from, takes in, they call it array-like. That's interesting. An array-like or iterable object to convert to an array. That's an interesting way to say it. Don't hate it. I don't hate it. Create an array. If I look at the array length, just this. Array-like. Do I want to call it array-like? Array-like. Or how about just iterable? Iterable object. Or just iterable. Yeah. Let's just go with that. Iterable of type iterable. Oh, and that's an optional one. You don't need to pass one in. If you do pass one in, so if you do pass one in, we're going to make our elements dot from, no, that doesn't work because we already created it. But we could make it this dot elements equal array dot from. That would be the easiest one. Yeah, the easiest way to do it. Array dot from the iterable. Oh, and look, that's what they call it too. Right, either an iterable or an array-like. Hey, what's the difference? What's the difference in interface? Oh, that's interesting. Constructors for derived classes must contain a superclass. Yep. A super call, I mean. Super. Super must be called before accessing this in the constructor of a derived class. Yeah, I forgot about that. So basically we're creating our, so let's do it right at the top. Okay. Generic type iterable. Yep, forgot about that. Now I wanted to find out the difference between array-like, array-like, what was it? Array-like. The array-like only refers to a type. Well, show it to me. Class foo implements array-like. Oh, it's generic. T. Okay, what am I missing? Length. Property length is missing in type foo. That's the only thing? An array like has a length and that's it? Oh, there's other things, okay. Index signature is missing. Ah, I see. So if I was to do, how does it work again? Index is of type string, and then the rest is, who cares, right? T. Does that work? Property length of type number is not assignable to string index type T. Why not? Oh, right, that's kind of a problem. Let's call it number, and then that works. But then it's saying, yeah, okay, whatever. Okay. So if it's got an iterable, we do this. If it doesn't have one, well, whatever. We just construct it empty. Let's just make sure that this works. So if I do const r, here's our array, and we're going to call it 1, 2, 3, 4, 5. And then I'm like, hey, let's make a stack. Cool. Const stack equals new stack. And I pass in my array. Good, no errors so far. Let's just bring in Quokka. And if we look at our stack, it's got elements 1, 2, 3, 4, 5. Cool. If I do size 5, good. If I do stack dot, no, I didn't implement these yet. Okay. All right. You know what? Let's keep that alive for now. Okay. We're good for the constructor of our stack. What else do we want in there? Well, the obvious ones are, of course, push, pop, and peek. But let's look at what else C# and Java does. I'm in the constructor here, okay. Properties count, which we call size. And do we need to play with that? We don't. Our abstract implementation takes care of that. or base, I should say, implementation. Clear. Remove all objects from the stack. We already have that. Don't need to worry about that. Contains determines whether an element is in the stack. Now, do we need to worry about the order? That's a good question, right? Because in the JavaScript array implementation of contains, which is includes, you start at the beginning of the array. And as soon as you hit something that matches, boom, that's, well, actually, does it return, do we return the index? No, it's a Boolean, right? Oh, so we don't care. Okay, cool. It's the remove that we're going to have to think about. Copy to. Copy is the stack to an existing one-dimensional array starting at the specified array index. I think I opted not to implement this. I don't think we're often going to end up doing that, and for the few times that we would, we can just manually do this. Spread operator being very useful for these things too. Equals, okay, that's interesting. Determines whether the specified object is equal to the current object, and that's inherited from object. Okay, but we don't have that in JavaScript. There is no equals inherited from the base object class that I know of. And what would really be the point of doing that instead of just a triple equal operator? Determines whether the specified object is equal to the current object. Oh, like equal in terms of value, or is like the same? Let's look at Java. Do they have one of those? So we've got empty, peek, pop, push, search. And then we've got a bunch that are inherited from our other ones. Add all, add element, capacity, clear, glow, blah, 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 blah. I wonder if, if it's inherited from class, object, get class, finalize, notify, wait. Contains all, copy into, elements equals. So they do have on the vector class, which is kind of an array from what I understand. Let's go look at the definition of that thing. Compares the specified object with this vector for equality. Returns true if and only if the specified object is also a list. Both lists have the same size, and all corresponding pairs of elements in the two lists are equal. Okay, so it's not like the same object, but that the values inside it are the same. That's what it's checking for. In other words, two lists are defined to be equal if they contain the same elements in the same order. Okay, that's interesting. Is that C#'s does it do the same thing? Where equals? And we're getting that from object, so let's go take a look at that. Determines whether the specified object is equal to the current object. And the following example shows a point class that overrides the equals method to provide value equality in a point3D class that is derived from point, because point overrides object that equals to test for value equality. The object equals method is not called. However, point3D equals calls point equals because point implements blah, 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 blah. Okay. Yeah, I get it. So you can do whatever you want. It doesn't tell you, though, how they implemented it for the stack. But I'm guessing it's similar to what they're doing for all collections. which is look at each item and see if it's of equal value. Do I want to get into that? What's the use case for this on an entire collection? When would you want to see, and how hard would it be just using the actual language? So let's say I had, objects. I'm just thinking, const object, and let's just make it simple. A has 13, and B has, I don't know, woof. There. Okay, cool. And let's call this object 1. And then this will be object 2. And it's going to be A as 13. Let's make a perfect example here first. See if we can do so. If we do this, whoops. If we do object 1 strictly equal to object 2, we're going to get a false. They're not the same object. What if I do this? No, we're also going to get false. So how do I, and that, I guess that's kind of the purpose of the is equal thing. I want to see if they have the same value. What would be a good way to implement this? And do I want to get into that? I can see it being useful in some situations. I can also see that it's probably not very performant because you kind of need to compare both. You need to iterate through both objects, all of their properties. I think this might be one of those things that I implement later if and when I feel that it's useful or upon requests. But for now, does our friend here implement this? I doubt it. Push add pop peak size contains is empty and clear. So he doesn't, right? What about this guy here? Methods. Wow, this guy's crazy wide API. Display, scan, grow. Content compare would be something similar to what were content equals. The equals function used to check whether values in this collection are equivalent. The compare function used by this collection to determine how to order its own values. No, that's not. So this guy implements it on all of his collections. Interesting. Let's look at how he does it. If it's simple enough, we might think of doing it. So he doesn't have a stack. He does augment the array class, I think, the array object. Let's see. Take facet, collections.js, generic collection. might be implemented in here. Map, enumerate, group, to array, from, filter, every, sum, all, blah, 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 blah. First iterator. Nope. So let's look at something. The queue would probably be, does he implement? Oh, he doesn't implement it on the DQ. Double-ended queue. I don't think so. Okay. So it's not on all of them. Don't know why, but. So how about we look at the sorted array, just for sorted array. Sorted array. How do you implement this? What was it called again? Compare content equals. Content equals. Oh, index of. Find value, push and shift, pop, shift, slice, swaps, reduce, right, min, max, 1, clear, equals. This dot array dot equals. Wait a minute. I didn't see an equal. Equals. Did I miss it? Was it there all along and I missed it? Okay. Equals. Equals. Returns whether this collection is equivalent to the given collection. Not to be confused with content equals, which is, in my mind, exactly the same thing. The equals function used to check whether values in this collection are equivalent. Okay, I'm not clear on the difference. Returns whether this collection is equivalent to the given collection. In general, collections are equivalent if they have the same content. However, length, order, and uniqueness must also be equivalent. Okay. If this collection or the collection on the left. Okay. For example, if the list blah 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 ho ho ho. Okay. And it does implement it in the DQ. So let's go take a look at the DQ. And let's not waste time and just go straight for equals. Find value, nope. Nope. I guess that's something that he monkey patches on top of. I'm gonna have to find where he does that. Can I just look at equals in this oh man, it's gonna give me so many list.js. Generic order. Generic order dot equals. No. Collection. Nope. Generic map. Yeah, so he puts it, okay, so straight on the object. Object dot equals, that's what he keeps using. Wait, is that a built-in thing in Java? I don't think it is. Never heard of it. MDN object dot equals. Object is provides same value. Which operation you should depend, double equals will perform a type conversion. We don't want that. This does not type conversion, no special handling. Same value equality. Addresses a final use. Determining whether two values are functionally identical in all contexts. This use case demonstrates an instance of the Liskov substitute principle. When to use object.is. In general, the only time object with special behavior towards zeros is likely to be of interest is in the pursuit of certain meta-programming schemes. Yep, that's not what we're looking for. Thank you. Shim object. Ah. Okay, that might be where shim object. Let's take a look at this. Shim object. Shim object. I'm feeling that's what we're looking for. Has, get, set, define each, for each map from is equals, whether the values are deeply equivalent. Performs a polymorphic, type-sensitive, deep equivalence comparison of any two values. Interesting. All right, guys, I'm gonna have to go. We will be continuing this probably in the coming days. I don't know, might intersperse some puzzles and exercises and katas in between. We'll see. Depends how I feel. This thing's not centered at all, is it? There we go. All right. Thanks for watching. See you tomorrow.